Welcome to This Explainer. Okay, today we're going to totally shift our perspective on what science actually is. For a lot of people, science feels like, well, a dusty old textbook filled with these rigid, unchanging facts. But the reality? The reality is far more fascinating. Science is really this dynamic, everyday toolkit for thinking. It's a way of looking at the world, embracing the stuff we don't know for sure, and just using good old logic to navigate our daily lives.
Okay, let's dive right into this with a frustration I know we all share. Picture this. You check your phone, the weather app promises beautiful sunshine, so you leave your umbrella at home. And then, bam! A few hours later, you're caught in an absolute downpour. It's incredibly annoying, right? But asking why these forecasts go wrong is actually the absolute perfect entry point into how the scientific method operates in the real world. Because, well, weather depends on just a massive array of constantly moving pieces. We're talking temperature, atmospheric pressure, humidity, wind speeds, the whole shebang. Now, forecasters use these highly sophisticated computer models to track all of this. But here's the catch. Even tiny, microscopic differences in those initial conditions compound. They grow exponentially over time. It's the classic butterfly effect in action. What starts as a tiny breeze on Monday can literally snowball into a completely different weather system by Friday. And that is exactly why forecasts are super reliable for a few hours, but get a lot more murky the further out you try to predict. Now, you might be thinking, wow, meteorology is just broken. But actually, here's the plot twist. A failing prediction isn't a weakness of science, it is literally its greatest strength. We usually view failure as this huge negative, right? But in the scientific toolkit, a failing prediction is the exact spark that drives discovery. It's nature's way of tapping us on the shoulder and saying, hey, your model of reality needs a crucial update.
So this brings us to a real fork in the road. When a prediction doesn't match reality, how do we react? In everyday life, man, it is so easy to just reject new ideas to protect what we already believe. We all do it. But the scientific toolkit demands a strict pivot based solely on evidence. If the evidence completely contradicts the belief, well, the belief is what has to change, not the evidence.
And that builds into a much broader, kind of humbling understanding. Even the most incredibly successful scientific theories have their limits. They might suddenly fail when we explore entirely new conditions or, simply when our instruments get a little more precise. Because of that, no scientific theory is ever final. None of them are beyond questioning. This inherent openness to being corrected by nature itself, that is the engine that helps us progressively map the universe.
Now, what's really interesting is how we can take these massive, grand ideas about theory and evidence and apply them to something highly specific, like a total solar eclipse. Historically, and honestly even today, these awe-inspiring celestial events generate massive amounts of fear and misinformation. It spreads like wildfire. So let's grab our toolkit and debunk a very specific modern-day myth together.
I bet you've seen a post exactly like this pop up on your feed at some point. Food should not be eaten during an eclipse because it becomes harmful. It is a surprisingly common viral claim that makes the rounds on social media every single time an eclipse approaches. It sounds super alarming, and without the right tools, it's pretty easy to see why someone might hit that share button just to be safe.
So how do we actually dismantle this? We pull out the skeptic's toolkit and start firing off some really simple scientific questions. First up, what physical change is actually occurring out there? Well, the moon is simply blocking the sun's light. That's it. Second, does the temperature change? Yeah, it might get slightly cooler for a few minutes, but nothing extreme. And third, the real kicker. Does food naturally go bad just because it sits in a shadow? Obviously not.
And just like that, by breaking the claim down into basic questions, we arrive at a pretty solid logical conclusion. There is absolutely no physical, chemical, or biological mechanism that supports the idea of food turning toxic during an eclipse. At the end of the day, an eclipse is just a spectacular play of shadows. By relying on our toolkit, we seamlessly disprove this viral myth. And hey, we didn't even need a PhD in astrophysics to do it.
All right, moving on to another absolute game changer in our toolkit, estimation. In school, we're almost always taught that precise, exact numbers are the only things that matter. But out in the real world, exact values aren't always necessary, especially when you're just starting to reason through a problem. Estimation isn't just taking a wild guess. It's a really deliberate strategy to identify the vital parts of a situation and run a quick, rough calculation just to see if an answer even makes logical sense.
To show you just how powerful this is, let's look at a super practical, everyday problem. Say you asked, how much rice would feed a family of 4 for an entire month? Now, at first glance,
That seems like a pretty complex logistics puzzle, but we can totally solve it. Or actually, scratch that. We can get a really good sense of the scale of it using rough estimation.
So step 1 in any good estimation, finding our baseline data. What is the fundamental quantity that actually matters here? It's human energy consumption. An average adult needs roughly 2,000 to 2,500 kilocalories a day. And that right there, that's the anchor for our entire thought process.
All right, with that baseline established, let's just assume for a second that all of their daily calorie needs are going to come from rice alone. We figure out how many calories 100 grams of uncooked rice provides once it's cooked, use that basic ratio to estimate the daily requirement for the whole family, and then just multiply it out for the month. Simple math, right?
But remember, and this is absolutely crucial, the goal here is not to calculate everything down to the exact decimal point of a single grain of rice. We just want to check if our eventual answer is in the right ballpark. If your calculation spits out that they need 100 grams for the entire month, your intuition immediately screams, no way, that's impossible. On the flip side, if it suggests a few tons, that's obviously way too much. Estimation builds up your intuition, it flags errors in your own thinking, and it keeps your answers firmly grounded in reality.
And honestly, this brings us to the absolute core message of this whole explainer. Science values careful reasoning perhaps much more than accurate calculations. Building intuition, questioning those viral myths we see online, understanding why complex systems like the weather are so darn hard to predict, these are all about logical confidence. Precise math is important, for sure, but having the fundamental reasoning skills to know if that math makes sense to begin with, now that is a true superpower.
So, here's the ultimate takeaway. This toolkit, it belongs to you. It's not locked away in some high-tech laboratory. It's just a better way of approaching your daily life with curiosity, healthy skepticism, and solid logic. So I'll leave you with this final, provocative thought. Look around you right now. What is one everyday problem, one random household question, or one minor mystery that you can estimate and solve today using this very toolkit? Seriously, try it out. You might be shocked by how clearly you can see the world when you embrace a little uncertainty and start estimating. Thanks for hanging out with me for this explainer, and remember, keep questioning everything.